Perfect numbers have captivated mathematicians and thinkers since ancient times, regarded as objects of study and speculation throughout history. But what is truly astonishing is that, despite thousands of years of research, these numbers remain fascinating to study today. What makes a perfect number so special that it has become such a sought-after rarity? The history of perfect numbers dates back to ancient Greece, intertwining mathematicians like René Descartes and Leonhard Euler, and the most interesting part is that it remains an intriguing topic for modern mathematicians. Descartes proposed rules about perfect numbers, but it was Euler who provided the first solid proofs. These mathematical geniuses laid the groundwork for the exploration and understanding of perfect numbers. First, let's define what a perfect number is. In simple terms, a perfect number is one that equals the sum of its proper divisors, that is, all its divisors except the number itself. For example, the number 6 is perfect because its divisors are 1, 2, and 3, and their sum is 6. Another example is the number 28, with divisors 1, 2, 4, 7, and 14, which also sum to 28. Euclid. The first to refer to them was none other than Euclid, in his influential work Elements, published around 300 BC. He had discovered 4 perfect numbers, and in his book, he revealed a surefire way to find others. It was a reliable method, though difficult and labor-intensive. Let's see, according to Euclid. If any numbers, starting from 1, are arranged in a doubling proportion until their total sum results in a prime number, and the total multiplied by the last number produces another number, the product will be a perfect number. For example, the sequence 1, 2, 4, 8, 16, 32, 64. 1 plus 2 is equal to 3, and since 3 is prime, we continue by multiplying 3 by the last number in the sequence, which is 2. 2 times 3 is equal to 6, which is a perfect number. Now, 1 plus 2 plus 4 is equal to 7, and since 7 is prime, multiply it by the last number in the sequence, 4. 7 times 4 is equal to 28, which is also a perfect number, and we continue the same process. 1 plus 2 plus 4 plus 8 is equal to 15, which is not prime, so we continue. 1 plus 2 plus 4 plus 8 plus 16 is equal to 31, and since 31 is prime, we multiply it by the last number in the sequence, 31 times 16 is equal to 496. And the result should be a perfect number. Is it? Four 96 can be divided by 1, 2, 4, 8, 16, 31, 62, 124, and 248. If we sum them, the result is 496, so it is indeed a perfect number. As you can see, the process is a bit long, but it can be simplified with a formula Euclid described, which we now know as the perfect number theorem, where p is a prime number. This formula links perfect numbers to Mersenne numbers, which are of the form and must be prime for the result to be a perfect number. Euclid did not manage to prove that this formula worked, but it was Euler who demonstrated that all even perfect numbers can be found using Euclid's formula, significantly expanding our knowledge of them. But an intriguing question arises: do odd perfect numbers exist? To this day, no one has found one, and many believe they may not exist, but this remains an unproven conjecture. Euclid did not only leave 4 of these select numbers, 6, 28, 496, and 8128, but he inspired generations of mathematicians to continue searching. However, it took almost 1,800 years before another perfect number was identified. This discovery marked a milestone in mathematics. Before that, the next significant study of perfect numbers was carried out by Nicomachus of Gerasa around 100 AD. In his Introduction to Arithmetic, he provides a classification of numbers based on perfect numbers. Nicomachus divided numbers into 3 classes. Abundant numbers, which have the property that the sum of their divisors is greater than the number. Deficient numbers, where the sum of their divisors is less than the number. Perfect numbers, which we have already defined. Nicomachus also described a series of properties of perfect numbers, without providing a proof and with some errors. 1. The nth perfect number has n digits. 2. All perfect numbers are even. 3. All perfect numbers end in 6 or 8 alternately. 4. Every perfect number is of the form where 2 raised to the power of p minus 1 is prime. 5. There are infinitely many perfect numbers. Nicomachus did not offer any justification for these properties. But what we know today is that statements 1 and 3 are false. Why? Let's see. The nth perfect number has m digits. 6, the first number, has 1 digit, so it fits. 28, the second number, has 2 digits, and so on. However, the fifth perfect number, discovered in 1456, is 33,550,336 and has 8 digits. Now the third statement becomes false when the sixth perfect number is discovered. In 1588, the Italian mathematician Pietro Cataldi found 2 perfect numbers, 8,589,869,056 and 137,438,691,328, where we can see that both the fifth and sixth numbers end in 6, making the statement false. The remaining statements are still unproven. It's impressive. And the eighth perfect number, discovered 2 centuries later, is even more so. Can you imagine how much work it must have taken to achieve this without a computer? It was identified by none other than the great Leonard Euler in 1772. It had 19 digits, and according to the 19th century English mathematician Peter Barlow, it was probably the largest that will ever be discovered. He was wrong. 2 decades after his death, the 9th perfect number was found, and thanks to advances in technology and number theory, the time between discoveries shortened to the point where, in this millennium, nearly 1 has been discovered each year. Now, we know a total of 51 perfect numbers. The most recent has 49,724,095 digits. The list of all perfect numbers can be found on the VAXA software website. It shows which perfect number it is, how many digits it has, the year, and of course, who discovered it. Perfect numbers are important because they are fascinating. That's why so many mathematicians have dedicated time and brainpower to finding the list we know today. Moreover, one of the most fascinating things about mathematics is that it often reveals wonders that we only come to understand over time, like why the number 7 is considered lucky.